Something is broadcasting from deep beneath the Antarctic ice. In one of the most isolated and enigmatic places on Earth, scientists have detected mysterious radio waves coming from a direction they never expected, straight up out of the frozen ground. These signals seem to defy the very laws of physics as we know them. The discovery has sent ripples through the scientific community, forcing physicists to question the fundamental rulebook of the universe. The story begins high in the sky, 40 kilometers above the vast white expanse of the Antarctic continent. Here, a sophisticated detector array, suspended from a massive helium balloon, silently listens. This is the Antarctic Impulsive Transient Antenna, or ANITA for short. Its mission was to scan the millions of square kilometers of ice below, searching for the faint, fleeting radio pulses generated by extremely high-energy particles from space colliding with the ice. The primary targets were elusive particles known as neutrinos. Often called ghost particles, neutrinos are almost massless, have no electric charge, and can pass through entire planets as if they were empty space. Trillions of them are passing through your body this very second, completely unnoticed.
The experiment was specifically looking for a very rare type of interaction. Scientists hoped to spot what's known as a tau neutrino. The idea was that a high-energy tau neutrino, originating from a cataclysmic event deep in the cosmos, would travel through space, enter the Earth, and just as it was about to exit on the other side, it would interact with an atom in the Antarctic ice. This interaction would produce a shower of secondary particles, which in turn would generate a distinct radio pulse that ANITA's antennas could detect. The key was that these events were expected to come from particles just grazing the Earth at a shallow angle.
But that's not what ANITA found. On several of its flights, the antennas picked up signals that were completely unexpected. They were indeed radio pulses, consistent with particle showers, but they weren't coming from a shallow angle. Instead, they were firing almost straight up out of the ice, at a steep angle of roughly 30 degrees below the horizon. This was profoundly strange. For a particle to arrive at ANITA's detector from such an angle, it would have had to travel through thousands of kilometers of solid rock and ice. And according to our current understanding of physics, that's simply impossible at these energy levels.
This is where the mystery deepens and challenges the core of modern physics. The established theory that describes all known fundamental forces and particles is called the Standard Model. It's been tested and confirmed for decades and serves as our comprehensive rulebook for how the universe works. According to this rulebook, the Earth should be completely opaque to high-energy particles. At the energy levels ANITA detected, no known particle, not even a hardy tau neutrino, should be able to complete such a journey through the planet's dense interior. The probability is so low that it's considered practically zero. Yet ANITA detected these signals not once, but on multiple occasions, suggesting it wasn't just a fluke or an error in the detector. The scientific community was baffled. Researchers from other major Antarctic experiments, like the IceCube Neutrino Observatory, which uses thousands of detectors buried deep within the ice, were asked to check their own data. They searched for any corresponding signals from the same direction in space that could explain ANITA's findings. They found nothing. This result effectively ruled out the last remaining possibility within the Standard Model, that the signals came from an incredibly intense, focused source of astrophysical neutrinos. The conclusion became unavoidable. As one physicist put it, if the events are real, they could be pointing to physics beyond the Standard Model.
This has opened the floodgates to a wave of new and exciting, though speculative, hypotheses. What could possibly travel through the Earth and create these signals? One of the leading ideas is the existence of a new, undiscovered particle. Some theories, like supersymmetry, predict the existence of heavier partner particles for the particles we already know. One such hypothetical particle, called a tau lepton, a supersymmetric partner to the tau lepton, could potentially have the right properties to make the impossible journey through the Earth before decaying in the ice and producing the observed radio pulse.
Other theories venture into even more exotic territory. Some researchers have suggested the signals could be related to the elusive nature of dark matter, the mysterious substance that makes up most of the matter in the universe but has never been directly detected. Perhaps these signals are the first faint signs of a strange new interaction with the dark matter that permeates our galaxy. And, as is often the case with such profound mysteries, more fringe ideas have been floated, including signals from a parallel universe existing alongside our own. While these ideas capture the imagination, scientists are focused on more testable hypotheses first. There's also the more mundane possibility that the signals are not from a new particle at all, but from an unusual reflection of a normal cosmic ray off a hidden structure within the ice, like a subsurface lake or a strange ice formation.
The mystery of the Antarctic signals is far from solved, but the quest for an answer is entering a new phase. ANITA itself has been retired, but a far more powerful and sensitive successor is now being prepared. This new mission is called the Payload for Ultra-High Energy Observations, or PUYO. It's a next-generation balloon-borne observatory designed specifically to be more than an order of magnitude more sensitive than ANITA. PUYO will fly over Antarctica, listening with unprecedented precision for more of these anomalous events. Its main goal is to determine once and for all if these signals are a recurring phenomenon, and if so, to gather enough data to finally unveil their true nature.
We are standing at a potential turning point in our understanding of the cosmos. The signals from beneath the ice represent a profound anomaly, a crack in our otherwise solid foundation of physics. Are they the first evidence of a new particle that will expand the standard model? Are they a clue that could lead us to understand dark matter? Or are they something else entirely, something no one has even thought of yet? The frozen continent is holding its secrets close, but with the new, more sensitive eyes of PUYO about to turn towards the ice, we may be on the verge of uncovering a truth about our universe that has been waiting, silently, beneath our feet all along. The investigation continues, and the entire world of physics is watching and waiting for the next signal.